Have you ever heard of stars that refuse to die? This isn't some cosmic ghost story, but the perplexing reality of what we call zombie stars. These celestial bodies, in a defiance of cosmic norms, seem to cheat death, surviving what appears to be their own supernova explosion. Picture a star, going through its usual life cycle, ready to fade into oblivion or burst into a supernova. But instead, it comes back to life, continuing to shine in the vast expanse of our universe. It's like watching a phoenix rise from its own stellar ashes. These zombie stars are not merely a curiosity, they challenge our understanding of stellar evolution, and open up a world of questions about the mechanisms that govern our cosmos. So, if you're ready to challenge what you know about the universe, it's time to delve into the world of these undying luminaries of the cosmos. To fully appreciate the peculiarity of zombie stars, we first need to understand the conventional life cycle of stars. Stars, just like living organisms, are born, they live, and eventually they die. The life of a star begins in a nebula, a vast cloud of gas and dust. It is within these interstellar nurseries where the magic happens. Gravity pulls the gas and dust together, and as they become denser, they heat up, giving birth to a new star. Once a star is born, it enters the longest phase of its life, known as the main sequence. This is the prime of a star's life, where it spends most of its time. Our sun, for example, is currently in this phase, steadily burning hydrogen into helium in its core. However, nothing lasts forever, and stars are no exception. As they exhaust their hydrogen fuel, they transition into the red giant phase. Their outer layers expand, and they become hundreds of times larger. They burn brighter, but they are also cooler, hence their reddish appearance. The fate of a star after this phase depends on its mass. Lower mass stars like our sun will shed their outer layers and leave behind a hot, dense core known as a white dwarf. This is the final stage of their life. They will cool over billions of years, eventually fading into black dwarf obscurity. But for massive stars, their story ends in a more dramatic fashion. They explode in a supernova, an event so powerful it briefly outshines an entire galaxy. After the explosion, what's left could become a neutron star or, if massive enough, collapse into a black hole. But zombie stars, they dance to a different cosmic tune. Imagine a star that after a catastrophic explosion springs back to life. That's a zombie star for you. In the grand cosmic theater, zombie stars are the ultimate enigma, defying our understanding of stellar life and death. Picture this: a star like our sun burns for billions of years, fusing hydrogen into helium in its core. As it ages, it expands into a red giant, eventually shedding its outer layers and cooling down into a white dwarf. A massive star, on the other hand, meets a more dramatic end. It explodes in a supernova, leaving behind either a neutron star or a black hole. But then we have the anomaly, the zombie stars. These celestial oddities, after undergoing the cataclysmic supernova explosion, don't fade into obscurity. No, they rise from their own stellar ashes, surviving the very event that should have heralded their end. Imagine a fireworks display, where instead of fading out, the sparks reignite, burning as bright as before. That's the spectacle of a zombie star. The question that tickles the curiosity of astronomers worldwide is, how is this possible? How does a star survive its own death? The supernova explosion is one of the most powerful events in the universe, capable of outshining entire galaxies. It's the grand finale, the final curtain call for a star, and yet zombie stars seem to take a bow, exit the stage, only to return for an encore. This stellar resurrection challenges our understanding of the cosmos. It pushes us to question and rethink our theories of stellar evolution. It's like finding an unexpected twist in an old familiar tale. A twist that leaves us scratching our heads but also opens up exciting new possibilities. So what might be causing this stellar resurrection? The answer might lie in a particular type of supernova, less powerful, but no less fascinating. But that's a story for another scene. For now, let's marvel at the mystery of zombie stars, the undying luminaries of the cosmos. Enter the type IX supernovae, a weaker cousin of the typical supernova explosions. Unlike their more powerful relatives, type IX supernovae are less energetic. They are the quiet whispers in the loud choir of cosmic explosions. Yet it's precisely this subdued nature that might give birth to the enigmatic zombie stars. Now let's dive a bit into the mechanics of these IAX supernovae. Normally, when a star explodes, the force is so great that it shatters the star, leaving nothing behind but a neutron star or a black hole. But in the case of a type IAX supernova, the explosion is less intense. It's like the difference between a demolition explosion and a controlled blast. The result? A part of the original star might survive the ordeal, leading to the birth of a zombie star. This theory suggests that zombie stars are not anomalies but are instead the remnants of these weaker supernovae, and there's evidence to back this up. Astronomers have observed stars that have undergone supernova explosions, yet continue to shine, a behavior consistent with the IAX supernova theory. But what's truly fascinating is the fact that these zombie stars, once reborn, can start a new life cycle. Imagine, a star exploding, surviving, and then going through the process of fusion all over again. It's like a phoenix rising from its ashes, ready to light up the universe once more. However, this theory is not without its challenges. While it explains the existence of zombie stars, it also raises new questions about the nature of supernovae and the life cycles of stars. For instance, what conditions lead to a type IAX supernova instead of a typical one? And how common are these events in the universe? But what does this mean for our understanding of the cosmos? Zombie stars are not just celestial curiosities, they have profound implications for our understanding of the universe. They open up a dimension of complexity in the life cycle of stars that was previously unimagined. We were content with a story that began in a nebula and ended in a supernova, but these undead stars insist we rethink this narrative. Imagine the life of a star like a grand play. We thought we knew the final act, the climactic end where the star goes supernova and departs from the cosmic stage. But then, enter the zombie star, refusing to bow out after the supposed finale, stubbornly shining on. The existence of these stars suggests that there might be alternative endings to this cosmic drama. Maybe there are encore performances we hadn't accounted for. Further, the zombie stars invite us to consider the possibility of cosmic recycling. Could these stars be gearing up for another life cycle, fusing elements and maybe even exploding again? If so, it's like they're rewriting the rules of stellar evolution, adding a plot twist in a tale we thought we knew. But perhaps the most exciting implication of these zombie stars is the unique window they provide into the intricacies of stellar physics. They offer a rare opportunity to study the mechanisms of supernova and the conditions that allow a star to survive such a cataclysmic event. They are like cosmic laboratories, presenting us with the chance to unravel the mysteries of the universe. In the grand theater of the cosmos, zombie stars play a fascinating role. They challenge our understanding, defy our expectations, and keep us on our toes. They remind us that the universe is full of surprises, and there's always more to learn, more to discover, and more to marvel at. As we continue our cosmic journey, these undying luminaries will undoubtedly continue to illuminate our path. In a universe teeming with mysteries, zombie stars stand out, challenging our perceptions and sparking our curiosity. These celestial anomalies defy the usual life cycle of stars, surviving terminal supernova explosions and continuing to shine in the cosmic theater. Their existence suggests that stellar deaths can be more diverse and complex than previously thought, opening up new avenues in our understanding of stellar physics. The theory of type IAX supernovae offers a plausible explanation for these undying luminaries, hinting at the possibility of less energetic supernovae that leave behind a remnant star. But there's so much more to learn, to observe, and to discover about these zombie stars. They could undergo another life cycle, fusing elements and possibly exploding again, becoming cosmic recyclers in the grand scheme of the universe. As we continue to unravel the mysteries of the universe, let the tale of the undying zombie stars inspire us to keep looking up and keep questioning.